All right, welcome back, guys. So I decided to 3D print some more rotors. This is a 4-pole rotor that's going to go the long way with these rectangle magnets. And so they'll go in laying that way. I printed the other part, but it broke when I was trying to put the magnets in, which meant that it wasn't secure enough. So I'm reprinting the top for this. And then I decided to do another one that was more round. And I've got 2 of the magnets in there. Now I've got to be really careful with this kind because these magnets, man, and I made 4 holes to slightly drill down in there and then put screws in there to hold it together. You can see how powerful these magnets are. I'm pretty far away from that rotor. I mean, look at the distance. And it's already going. It's already making it move. Anyway, let me get the rest of the magnets in there and we'll see what we can do. Stay tuned. Ooh, I got to be careful with these. These are some powerful magnets. But I got all 4 of them in there. And now I got to put some screws in there. And then we will see what we will see. Stay tuned. So it's going to work pretty good. You can see it's bouncing up and down on that. Oh, well, it can only go so far because it's not there, but that's, yeah. I should pull it up a little bit more, which I can do, so that I have more of a bounce. All right, stay tuned. Yeah, so I have more of a space underneath there, so now it has a nice bounce, a good magnet. I'm curious, I'm wondering if this distance if it will still work, if it will still cause a rotation. I've got to make a new top too, because this top, when I bolt it down, it pushes pressure on the bearing and causes it not to float like this. It's floating like this now nicely because I don't have any of the screws in. All right, let me see what I can do. Stay tuned. Wow, even at that distance, I'm getting a decent thing, and this is at 12 volts. That's incredible. I should put the bigger coils in there and see what that does. Put these behemoths in there. That's amazing. Let me turn it down and see how low I can go. Really good. That's crazy. I didn't think it could go that. I didn't think it would. Oh, these are powerful magnets. That's why. There's 6 volts. Still going really well. It's a nice little rotor. Thing's pretty powerful. 4 volts. Let's go back up again. There's 12 volts. Looking good. All right, stay tuned. All right, so I've created another rotor with those massive 2-inch by, I think it's 2-inch by 3/4 inch rectangle mags. This thing's a beast. It has a lot of flywheel action. But it's also just sitting on the maglev there. So, yeah. I have another one that's printing right now for the 1-inch square mags. Since I can't go to work right now because of this, I've been doing a lot of playing around with Fusion. So let's get this hooked up to the JL94 circuit, the dual circuit, and see what happens. Stay tuned. All right, so I got the dual JL94 circuit hooked up. Let's see what this guy will do. Let me turn it down though. So there's 8 volts. She's flying. Really good output. That's 8 volts. Let's turn it down a little bit more. There's 5 volts. Yeah, it's looking good. Really good output, especially for 5 volt or 6 volts. Let's turn it up. Here's 11 volts. Yeah, that's a little dangerous. Woo, that thing is flying. Let's see what kind of torque we got. Oh, yeah, that's got some good torque. $11 volts. Let's turn it up just a little bit more. There's, oops, there's 12 volts exactly, 1201. All right, that's a little bit too much. Let's turn it down. I don't know how much I trust that PLA to hold on to that without the tape around it. But yeah, it's working pretty good. All right. Turn it off here. See what we got here. I burn my hand. So that should hold on okay, but I don't know. You know, that's not a lot of PLA to hold it. Yeah, that's cool. Next. So I got to take this guy apart because I have a new rotor for this, but look at what happened. Look at that crack. Ooh, man, if that came flying off, that is a wicked crack too. Yeah, I have a better rotor setup for this. One that can't crack like that because there's no arms to it. So stay tuned. Yeah, I can see the design flaw. Yeah, there's the crack there, and it's even moving over here. I shouldn't have put it on this base here. I should have made it thicker is what I should have done. I should have came down in a slope like that. I mean, not that it would have ripped off, but still, damn, in the garbage. What a waste. Stay tuned. All right, so I have another new rotor. This one is a little bit more secure and safe. It's really locked in there. I've only got about 20 millimeters of the magnet showing. So it should be good. I think it'll still activate even from the distance of these two coils. If not, I'll move them in, but I think it will. So let me get the top on. I could probably run it without the top. Yeah, and it's funny because without the top, it floats better on the maglev. With the top, it kind of gets locked in because I didn't square the top up properly. But let me get it hooked up. This is at 8 volts. I'm getting really good output and really good speed. I got to turn it down. It's scaring me a little bit. There's 7 volts. I got to turn it down some more. There's 5 volts. I'm comfortable with 5 volts. This thing's got a lot of torque too. Oh, burns my hand trying to stop it. At 5 volts, I don't get a lot of output, but that's to be expected. So let's turn it up just a little bit. There's 6.9 volts. It's got a really nice rotation. Doesn't look like there's a lot of unbalance on this one. Somehow I think I got disconnected, so I don't know how much you got in there. Anyway, we're at 6.97 volts. Got a really, and again, I don't know if I lost some of the footage. Really level, nice speed. 7 volts is a really good voltage for this, but let me turn it up. Here's 11 volts. Yeah, that's getting a little scary. I don't know if I trust the PLA. In fact, let me turn it back down. I don't trust the PLA. I gotta rig up a blast shield. I don't have enough acrylic. Oh, I do have enough acrylic. No, that's glass. I've got to get myself, I used to have a huge sheet of acrylic, but I used it all. Anyway, yeah, at 5 volts, I'm getting almost no output, but plenty of input. Let's turn it up a little bit. 8 volts, 9 volts, getting some decent output. Again, some really nice level, not hardly any vibrations. Let's come back here. All right, I think that's good enough. Because again, I don't know that I trust the PLA, I trust my builds. But, and I've only had one ever pop on me, and that was a complete neglect. That was on one of my old Newman motors where I forgot to secure one of the heads. But I've never had a PLA part break on me from lack of support. So yeah, what I need to do is put these coils on some kind of sliding rig so I can see how far out I could go from these particular magnets. These are great bearings. This thing will spin forever. Got a lot of inertia. All right, I got another one in the pot ready to brew out. Let's stay tuned. All right, so I just finished running this guy, and I decided to print out another rotor using those very heavy, very powerful rectangle neo mags. And there's plenty of meat on this, so I think I can run this guy at high speed. But man, it's scary trying to get these magnets in there. Getting the first one in is okay. The second one is really scary. The third and fourth one go in easy because of the repulsion factor. Because I have south, south, north, north. So north, south, or something like that. They're definitely opposite poles all the way around. Because that's how I like to run it. And this is really powerful. So I don't even think I need the coils this close. But let me get it in there, excuse me, and see what we can do. Stay tuned. Yes, I think that's going to work out really good. Again, I have the repulsive maglev set up. I'm pretty sure these will be fine because these are powerful magnets. I just got to put the top back on and get it going. This stand turned out to be pretty good. I used it for a lot of different setups. This is what it was originally set up for, this monster right here, which I think I'm going to run again. I think I'm also going to take the magnets out and rig up a new rotor for it, but this one works really well. Yeah, let me get that stuff off of there. All right, stay tuned. Yeah, this thing is running really good. I'm getting a solid output. Those are really powerful magnets. That's only 9 volts. Let me turn it down a little bit. There's 6 volts. Man, that thing is like a little engine. Oh, that's running really nice. I don't know how much I trust that PLA though, but yeah, I'm even getting solid output at 6 volts. And that's with the coils pretty far away. Here, let's crank it up. There's 11 volts. Oh man, that's scary. Yeah, I'm going to turn it down. That's a little bit too scary for me. I have to rig up a barrier here and here, and I do have enough acrylic to do that, so that's what I'm going to do next. I'm going to rig up a barrier just in case, because woo! I'd like to check out the RPMs on that. So that's 5 volts. Oh, that is sweet. Yeah, I'm going to do a lot more experimenting with this. I didn't think this guy was going to be that good, but oh, it is nice. I made sure that the magnets were precisely and exactly in a um, set up in a way where it was equal spacing down to the millimeter. Actually, it was perfect all the way around. Oh, that's got some torque on it too. Yeah, that is nice. Woo! I really like that. Oh, there's a little bit of wobble in that. What is that? The wobble in the? Oh, it's just because of the. Oh, I see what it is. Okay. Yeah, that thing is wicked. All right, man. Thanks for watching, guys. Ciao.